Alright, great. Welcome to the discussion on question 2. Let's take a look. Question 2 says, is the standard deviation of the numbers a, b and c equal to the standard deviation of 4, 8 and 12? Statement 1 says 2 into c minus a is 16. Statement 2, 5b minus a equal to 4 into b plus 1. So as we discussed in the first question, here also we need to know a concept. Quite obviously, this is the concept standard deviation from statistics. Let's take a look at that concept first and all the nuances related to it. So here's your concept. The concept of standard deviation says that the formula is like this: square root of summation x minus m the whole square upon n, where m is the mean of all values of x, equal to sum of all the values upon n, where n is the number of values and summation represents the sum of all the such values. So quite complicated. Don't even worry about this formula. I'm just going to explain to you what standard deviation is and step-by-step procedure rather than going through this very strange looking formula. Okay, so don't worry at all about this formula. We'll just understand what SD is, right? Standard deviation. We'll take this example 1, 2, 3. Okay, so basically standard deviation gives us an idea about the deviation of the terms from the mean. So our first step is always to find the mean and the deviation of the terms from the mean. So in this example, our mean is what? It is 3 plus 2 plus 1, which is 3 plus 2, 5 plus 1, 6. 6 upon 3, which is 2. That's how mean or average is defined. We take the sum of numbers divided by the number of elements. Now our next step will be to find the deviations from the mean. Alright, so let's find the deviations of each terms from the mean. The three values are 1, 2 and 3. We know the mean is 2. So the deviation of 3 is 1, right? It's 1 more than 2. The deviation of 2 is 0, right? There is no deviation of 2 from 2 itself. And 1, the deviation of 1 from 2 is minus 1. That is, 1 is minus 1 away from 2. It's 2 minus 1 will give you 1. Great. Now, in statistics, these deviations are then converted to standard deviations. Okay, these are the steps. The first step after finding the deviation is we look at the squares of the deviation. So just take the squares, right? Alright, so just square them. So we get 1, 0, 1, right? And then the next step is we take the squares of these deviations. Okay, so if we add these squares, so we get 1 and 1, which is 2, and 0, so the entire sum is 2, and take the average. So there are 3 elements, so sum will be 2 divided by the number of elements, which is 3, and I'll get the value as 2 by 3. And SD is nothing but the square root of this. So square root of 2 by 3. There is a term called variance for this number, which I'll explain later. Right now don't need to worry about that. But SD is simply the square root of that. So square root of 2 by 3, SD is root 2 by 3. So again the steps: find the mean, alright, then find the deviations. You got 1, 0, minus 1, take the squares, add the squares, take the average and take the square root, and that's your SD. So hope you know, rather than memorizing that formula, these steps would help you to always find the SD of any set much easily. Alright, but you know, we will not even need most of the problems to find the SD. The main line will be this, the main point will be this, that deviations, what are the deviations from the mean? Because GMAT tests, a lot of the questions of GMAT test this concept a lot, and even in this question we'll see how that is played out. Okay, so let's take a look. Try this on your own and use the above steps to calculate the SD for 4, 5, 6. Alright, go ahead. So first find the mean. 6 plus 4, 10, 10 plus 5, 15, 15 by 3, 5. So mean is 5. What are the deviations from the mean? 6 is 1 away, so 1. 5 is 0 away, so 0. And 4 is minus 1, so minus 1. Same deviations. So you might, we'll go ahead and calculate, but at this point itself, I think you can say that the SD will be same, right? Because deviations are same. Now we're going to square them, so that's going to be same. We're going to take the average, that's going to be the same because there are 3 elements. Then the SD is root of that, and therefore we get the same SD. So this is the key thing to observe, that two sets which have the same number of elements and which have the same deviations relative to the mean have the same SD. Alright, so please make a note of this. Here's an example. 1, 2, 3 will have the same SD as 4, 5, 6, which will have the same SD as 10, 11, 12, which will have the same SD as 100, 101, 102, which will also have the same SD as, for example, x comma x plus 1 comma x plus 2, where x is any integer, positive integer, right? So it's gonna have the same SD. Doesn't matter because deviations are going to be the same in all of them. The deviation from the mean are 1. So 1 this side, 1 that side, same thing here. So SD is gonna be same. Now 6 comma 8 comma 10 will also have the same SD as x comma x plus 2 comma x plus 4. Why? Because same concept. Here the deviations is plus 2 and minus 2, because you realize that the middle one is 8 and it's again the mean, if you calculate, is going to be 8. Here also, as you can see, it is evenly spread, and we'll see this later. It's called an arithmetic progression. So the difference is 2. So here this number is 2 more than the middle one. This number is 2 less than the middle one. The mean is going to come out to be the middle one. The deviations are plus 2, 0 and minus 2. Thus, these two sets have the same deviations, the same number of elements, and therefore the SD will be the same. Alright, so now I think we've got some mastery over these concepts, and now we can apply them to this problem. Let's take a look. Is the standard deviation of the numbers a, b and c equal to the standard deviation of 4, 8, 12? So first, what is the standard deviation of 4, 8, 12? Let's look at the mean. First step, mean is 8, right? 4 plus 8 plus 12, 12 plus 12, 24, 24 by 3, 8. And now the deviations are 12 is plus 4, right? 4 more than 8. 8 is 0, deviation is 0, and 4 is minus 4. So these are your deviations, and the number of terms are 3. We can go ahead and find the SD, but you'll observe that later I'll show you that this is the main step where we can actually stop. But anyway, let's calculate it. So square of the deviations, as we did earlier, square them, 16, 0, 16, and take the average. So average of this would be 16 plus 0 plus 16 by 3, which is 32 by 3, and SD is root of that, so root of 32 by 3. Right, but like I said, for the test, these 3 steps we need not do. I'll show you why in a little bit as we go ahead. Let's look at statement 1. Statement 1 says c minus a equal to 8. Now, the question is, does it give us enough information to find the SD of A, B and C and compare it with the SD of 4, 8 and 12? Okay. Now, does that give us any idea about B? Not at all, right? It just tells us that C and A, the difference is 8. So B, information about B is missing, and hence this statement will not be enough to tell us anything about the standard deviation of A, B and C, and hence we won't be able to compare it with 4, 8, 12. Hence statement 1 is not sufficient to answer this question. I hope that's clear. Right, C minus A is 8, gives us information about A and C, but there is no information about B. We cannot deduce or infer anything about the SD of A, B and C. Let's move to the statement 2. Statement 2 says 5B minus A is 4B plus 4. Rearrange it. Take the 4B this side. It will become 5B minus 4B, which will be B. And leave this A there. Minus A equal to 4 comes here. So the difference between B and A is 4. Is that enough to answer the question? Again, remember, the common mistake is that students often combine the two statements. Right now we are not combining, we're only checking the statement 2 alone. Does it give us any information about C? Not at all. We do not know where C is. We know difference of A and B is 4, but that doesn't tell us the SD of A, B and C, because we need to know where C with respect to A and B as well. Therefore, even statement 2 is not sufficient to answer the question, and therefore we need to do the next step, which is combine the two statements. Alright, remember this, that whenever 1 is ns, that is 1 is not sufficient, and 2 is also ns, 2 is not sufficient, that is only then that we do this step, which is combining the two statements. Alright, let's do it. Combine the two statements. Statement 1, c minus a is 8, and statement 2, b minus a equal to 4. Now analyze that. It looks like, if we don't analyze it further, you might be tempted to say, oh well, even at first glance doesn't seem to tell me anything about SD. I don't know what is A, I don't know what is B, I don't know what is C. But recollect that I don't need to know A, B and C. I only need to know what are the deviations relative to the mean. If you notice this and if you observe it carefully, you realize that this A, B and C are all equidistant. B turns out to be in the middle, right? It is 4 more than A. C turns out to be the biggest, which is 8 more than A, and A turns out to be the least, right? So just to see that a little bit clearly, let's say that B is X, then A will be X minus 4, correct? Right? Because A is 4 less than B, and C, which will be 4 more than B, right? Because C is 8 more than A, and B is X minus 4, so C becomes X plus 4. Alright, so what happens, as you can now see, that A is X minus 4 right there, okay, B, which is X, comes here, and C, which is X plus 4, comes here. So now you can observe that this looks like an AP, arithmetic progression. So if I take the mean or the average, what do we get? X minus 4 plus X plus 4 divided by 3. You will notice that 4 will cancel. You get 3x divided by 3, right? And that will be X itself. So the average is X. The deviations are what? Plus 4, that's right there. The deviation of X from itself is 0, and the deviation of this last term is minus 4. Thus, we found that the deviations of A, B and C are minus 4, 0 and 8. And now comes the important step. We could go ahead and calculate the SD from here, right? Take the squares, take the average and take the root. But at this point, can we stop? Because we know that 4, 8, 12 also has the same the same deviations, minus 4, 0, 4. This set also has the same deviations, minus 4, 0, 4. There are 3 elements in it, and here also there are 3 elements, and therefore we know now that the two will have the same SD. Therefore, together the two statements are sufficient, as we've been able to answer that a definite yes, that the standard deviation of the two are the same, and hence together the statements are sufficient, and the answer is C, together sufficient. Hope that's very clear. Just go through the steps once again. We've realized that A, B and C are all equidistant. We can just take a little help here by taking a variable for B, which is the middle one. We realize that A is 4 less, C is 4 more. If we look at the deviations and the mean, we realize the mean is the middle value. The deviations are minus 4, 0, 4. The original set that we had, 4, 8, 12, also had the same deviations. Both have the same number of elements. And at this point, even without calculating the SD, we can conclude that the two standard deviations are the same. Hence, together the two statements are sufficient. Answer is C. Hope that's clear. Alright, very good question, lot of good concepts, and mainly the observation of the SD. No need to, as you improve, you'll be able to do it much faster even without do too much of all this calculation. Great. We'll see a small variant in the next video, a what if scenario where we change a little bit, and we'll see how that plays out. Alright.